everyone, thanks for coming here. We are group number D. I'm Gus.
I'm Andreas.
And I'm Dave.
Yeah. And well, as you may see here, can we turn the slide off?
So,
yeah, as you may see here, we're happy to talk to you 30 minutes about complex systems and linguistics. So, a little bit of what we're going to talk about in this 30 minutes. First, we're going to say something about language and some history and context of people who studied language and some important questions that have been asked about language. And then we're going to move on to complex systems and how it can relate to language and the study of language. And in the end, we're going to show you some computer simulations and the mathematics of a simple game that can say how language evolves, and called the evolutionary language game. So, what is language? And if you never ask yourself this question, it's not as simple as it sounds. There are many phases of languages, and there are many ways to look at this question, and depending on the way you look at it, it has a different answer. So by the end of this part of the presentation, what we want is that you can see this multidimensional aspect of language. It's really hard to, we're going to give you now a little bit of a history of how this has been studied. And as every history is a little bit too difficult to find a starting point to start to tell it. So we choose the starting point where a lot of the important questions in science have been asked for the first time, or maybe well structured for the first time. Does anyone want to guess where, when and where? Yeah, many of you thought, yeah? Many of you thought about it, but no one said anything. Ancient Greece, Athens. So this cool dude there. One of his dialogues, it's about the origins and the words of words. And there are three guys discussing if how does a word relate to its object? Is there an inherent link between a word and its object, or is just a random thing we associate and we all agree to call something by its name? So Cratylus, one of the three dudes, is a disciple of Heraclitus, and he's the one who's famous for saying that you cannot step in the same river twice, and everything changes. So what he says is that like the only constant thing in history is that it changes, and so it's the same in languages. So there's nothing that can link a word specific to a specific object, but it's time. And then Hermogenes, he comes with a different thing, and he says, no. And remember that at this time, the word for them, they all speak the same language, or they don't speak. They are barbarians. They just don't speak language. So they all speak the same language. And what Hermogenes says is that no, an object and a word, they are connected, and the deviations of this connection are degeneracies. And then Socrates comes in, and he finds a middle ground. He says, yeah, no matter, like as you build an hammer, no matter what iron you use, it's still a hammer, if you build it in the right form. And it's the same thing with words. No matter what syllables you use or what sounds you use, if it's the same form, then it still relates to the same object, and it's connected. And that's connected to, you may have studied the theory of forms in high school or thing. Played the theory of forms, and that's really how he derives the theory of forms. So fast forward many years. This guy, Sir William Jones, he was a how do you call it, justice in British India, and by the age of 10, he learned over 8 languages, quite proficiency. And while he was judging things in India, he had a hobby of studying the origin of languages. And he was quite fluent in Sanskrit, Greek, and Latin. And what he noticed is like their grammatic similarities and their structural similarities were so great that there is no possibility they didn't have a common ancestor. And now we find that that's true, and that's what we call the Indo-European language group. So he was the first one to study that, and so he came to see language by this historic perspective of evolution of language, of how language divides and everything. Kind of what Darwin would do a few years later with language. And now we come to the father of modern linguistics, Ferdinand de Saussure. He was a teacher, and he was the first guy who like a lot of people was studying how language formed and everything, and he was the first one to see language as a system of symbols. And what he was interested in is how these symbols they interact between themselves and how they how they relate to the object, but also how they relate to themselves. So he has two phrases that kind of summarize this point. Is like a symbol only has value as it relates to all other symbols. So you may get a hint of how it's going to play out afterwards. But the only value of a symbol is how it can be viewed in relates to other symbols, and also that language can be seen as a game of chess. It's nice to see how it got there, but you can study its future just by seeing its current position. And yes, he was also the father of semiotics. That's another field of science that kind of divided from linguistics after that, but that also relates to symbols. And lastly, there's this other guy, Noam Chomsky. You've probably heard of him. He has some really strong political opinions. But he was also, he's most importantly, a very famous linguist. And he started a school called generativism. And what he wanted to answer is, he started off with two questions. How do children learn language so fast? And it sounds like a trivial question, but it isn't. And also, how can we, without really knowing the rules of grammar, construct infinitely grammatically correct sentences? And he started the hypothesis, which then evolved into this school of thought, that we are born with universal grammar. We are born with an inherent language, and we have innate capacity to learn this language, to learn another language by mapping this another language to our universal language. And he has quite a few empirical proofs to that. And one of the things is like all children, independently of what language they learn at their early years, they all go through the same phases. So even like Chinese or English, they are completely different grammars. They are structurally very different. But even so, if a kid is learning Chinese, it goes through the same steps of development as a kid learning English. So there was his theory. So now a question for you. How many colors are there in a rainbow? Anyone? No, it's not a difficult question. All right, for me it's 5. 7. So you might think that's a dumb question for a presentation about language, but you may believe it or not, the way you answer this question really affects the way you see the world. And I'll give you an example. Let's see, this is the spectrum of colors of light. And I say we have 5 colors. And I remember this birthday of my mother, and I took her to dinner and everything, and she was wearing a really nice red shirt. And let's say she was wearing a shirt that has this color. And I say I know 5 colors, and you say you know 7 colors. So let's see. So I remember my mother. When I remember, my mother was wearing red. But when you remember, my mother could be wearing orange. And that's actually proven experiment, and it really, the way you can name colors really affects the way you remember the word after that. And that's called, that's also something in linguistics, and it's called the Sapir-Whorf hypothesis. And it says that the structures of a language affects the way its speakers think about the world. And it was made by 2 scientists, and they had a few examples of that, just to start with this hypothesis. And that's also one of the most controversial things in linguistics, questions in linguistics so far. So for instance, Eskimos, they have over 100 words for snow. And it makes sense because the whole world is snow. So they can say, for instance, yeah, meet me there where the snow is kind of gray and a little bit yeah, thick, and that's a word for them. Or meet me there where the snow is freshly fallen and in the form of a triangle, and that's another word. Also, the Hopi Indians in the Arizona, they don't have what the spatial metaphor for time like we do. And so they have a really difficult time. When they think about the world, they have a really difficult time of seeing what came before what in the past, and also predicting and forecasting the future. And that's influencing their language. A few other examples, for instance, there's a tribe in the Amazon, the Pirahã tribe, and that's one of the last tribes that have really limited contact with the modern world. And they have 3 different words for numbers only. They have a word for 1, they have a word for 2, and they have a word for many. And that's more than 2 actually. And for instance, there's another tribe that has, they look at their hands, they have 1, 2, 3, 4, 5, and then more than 1 hand. And that really affects the way they can do arithmetics. For instance, they have R-level arithmetics up to 5, and then after 5 it completely goes away. Then they cannot sum, like they can sum 2 with 2, 2 with 3, but ask them to sum 4 with 5, and they don't know. And ask them how many kids they have, and they say many, or and again, it really influences the way they see the world. Some, like, we, for instance, when we say where's the door, we say over there, and yeah, I have a pain in my left foot, but there's less egocentric languages, for instance, the Aboriginals in Australia, and they say like, okay, instead of me being the center of things, they all references by the outside things. So for instance, if I say I have a pain in my left foot, now I have a pain in the foot that is facing the door. And that's also affects the way they see the world. And so to prove this hypothesis, there were also a few constructs. For instance, the Lodgepan language is they constructed that language to remove any ambiguity they can in the language. So anything you want to say in that language, you can say really precisely, without ambiguity or without any misunderstandings. And that's kind of in between the actual language and the programming language, if that's easier to imagine. But there's also Tokipona language, which is a language that has only 130 words, and then you can learn in 30 hours. And what they wanted, they say, okay, misunderstandings and ambiguity are inherent to any communication. So what we do when you speak Tokipona is like, I have this really complex concept that I want to say to you, and but you have to deconstruct it and translate it to this few core concepts, express it, and then the person listening to it has to take these few core concepts and construct it again using his own view of the world and how these concepts correlate, and then it gets its own meaning. So they assume that they all have different meanings to the word. So far, I hope you get that language is really important. But there's one last guy I want to talk to you about, and that's Ludwig Wittgenstein. And this was one of the richest persons in Austria. He inherited a lot of money. He was one of the only surviving sons of the second richest family in Austria at his time, just after the Habsburgs. And he had a lot of time to think. And one day he was reading a newspaper, and he was reading a story about a judge who was judging an accident, a traffic accident, and he asked everyone involved in the process to reenact the accident or make the accident happen again live, so he could judge. And then Wittgenstein looked at that and asked himself, why is it that a lot of people who have, like lawyers and important judges and everything, who have a lot of really good dominance over language, why is it that they cannot express what happened and they must show what happened? And yeah, he asked himself this question a lot, and then he went and bought a cabin in Norway, isolated himself for a few years trying to answer this question. And what came out of this is one of the biggest and most complex books in modern philosophy, where he says that all problems in philosophy and all problems of the world are problems of communication. It's problems when we cannot express exactly what is on our mind to another mind. And so he thought that communication and language are the most important things. He actually thought that so much that after he wrote that book, he said, all problems in the world are solved, all problems in philosophy are solved, and he went to teach kindergarten in Germany. And he came up with two really quotes that summarize what he thought is like, the limits of my word is the limits of my language. So my word is as big as my language can express it. And also, whereof one cannot speak, thereof one must be silent. You can either speak it and speak it very clearly in 2 sentences, or you cannot speak it at all and it must be shown. So it's kind of a reminder that we can sometimes speak more consciously. So you might have been asking, some nice stories, but how does complex systems fit into it? So there's a lot of ways you can look at language, and I hope you noticed that. Another way to look at it is by its function, or what functions it plays on our society and our other systems. And so for that, I'm going to let Andreas talk a little bit.
Well, that's right. The functionalistic perspective then. And this is sort of where the Carson approach really comes into play. Because if you view language mainly as a tool for communication, it's quite natural to view language in a very complicated social context, which has evolved it, just as with the culture, for instance. But one might want to ask the question, why would we want to complicate language? I mean, I've studied French, I know it can be difficult sometimes as it is. Well, language has certain properties that we often associate with other complex systems. For instance, there are certain dynamic properties, such as the use of language and how language evolves over time. And the use of language is, of course, a very active process. Sure, I learned some grammatical rules back in elementary school, but I don't really think about them now when I speak. And this quote really captures this in a way that, and it says that a language is to be identified with a living capability by which its speakers produce and understand utterances, not with the observed products of the acts of speaking and writing. And I think that this, the living capability of language is a very important concept, because it also encapsulates the way that language grows and changes over time. Because it's much more like a living organism that changes gradually and perhaps a bit chaotic sometimes. And it's not really put together and designed in a way that perhaps like it's car is. But even making this sort of division of the dynamic properties is a bit of an oversimplification, because it's a bit more complicated than that. Language changes as it is used. And this is where usage-based grammar really comes in, and the fact that language can be seen as an emergent property of local interactions between individuals. arguing that grammatic rules are more used to model the way, model a language, how it works, rather than actually dictate how a language actually is put together. And these local interactions, and I mean this is a very local interaction based on language, I think we can all agree on that. Of course this is very, everyone has, language sort of exists on different scales. We have a collective view of perhaps English in this case, and I have a certain view of language, and it might be different from yours and yours. And what I sort of, how I say, how I phrase myself is very much influenced by my past experiences with language. And of course, it's a very social context. We are classmates. We're going to spend next 2 years together. So I'm pretty keen on not making a complete fool out of myself. Yeah, and then there's also the biological side of things, sort of the biological limitations, and what I say, how I say it, very influenced by the cognitive processes within my brain. And it's expanding on these cognitive processes. They're also a bit what sort of governs how grammar is built up over time, because we like to categorize things as humans. We sort of put things together, we sort of recognize what order they occur. And historically this can be seen in certain cases, because we have a way of, sure, if I want to say something, if I want to propose to someone, I could say, I want to marry you, or I could say, I want marriage with you. But I'm far more likely to choose the first one, because even though both are equally valid, of course, and both get the point across, we don't use the second one, by convention, basically. And this cognitive processes also comes into play with the how certain words, grammar evolves, grammatic rules evolve over time. For instance, these examples from English where I am, she is, and they have sort of been abbreviated, and certain words has begun to, has been transformed into specific words. And this is all well and good. And language also has certain other properties that we of course associate with other complex systems. And going back to sort of tree view here. Well, if you remember the first lecture, where Timmy and Alvin talked about chaos theory and strange attractors and sort of these things, language sort of has similar structures, sort of core archetypical phonological patterns, which are of course shared between many different sort of natural languages in the world. But fractal structure is also, as I said before, it exists. Language exists within each and every individual, and on a more collective scale. So it changes over all these different levels. But perhaps the best example of a fractal structure within language is the self-similarity, especially the one shown by the sixth power law. It states that the relative frequency of a word is inversely proportional to its rank. This means that the most used word in a given text is used twice as many times as the second most used word, and so on. And this can be seen whether you look at a news article, a website, a book, or even the entire Wikipedia, for instance, follows this. This applies to all natural languages in the world, which is quite interesting. And of course, these types of power laws occur in many different other complex systems. And of course, mentioned last week during the discussion, I talked about how the distribution of city population in the country sort of follows these similar curves. And well, I've sort of argued for why we can view language as a complex system. And of course, with complex systems comes programming and computational models. These sort of allow us to really quantify linguistics research and sort of study it, allow us to study other problems such as the evolution of language and historical linguistics over time, over long time periods. In the old days, you find one book in ancient Greece and one book in Rome, and you sort of put the things together, sort of interpolate over things. But now you can really model different principles and basic principles between the evolution of language, and sort of can also be used to study how we learn language, both the first languages and the second languages, and so on. And as I said earlier, the CAST approach really encapsulates all of these different subfields, the cognitive linguistics, the social linguistics, and all these different aspects. and sort of gives a more coherent view altogether. And now I think Philip is going to talk a bit about the example of evolution of language.
Now we have heard a bit about linguistics and also how and why we should use a cost perspective to study linguistics. But we haven't actually seen how we can apply this. So what I'm going to show you is a simulation done in 1999 by the two researchers, Novak and Krakauer, where they did a simulation of the evolution of language using game theory. So we're going to have a look at this game. And the first simulation I'm going to call the basic evolutionary language game. It basically consists of a group of early hominids who is trying out verbal communication. So what we're going to do is we're going to do a round-based game where in each round every individual in this community is trying to communicate with every other individual. Since they are early hominids, they haven't gotten a very developed brain yet. So we can assume that they only recognize a finite number of objects and they can only use a finite number of sounds describing. Each individual has this internal language, which then can be described by two matrices, one speaking matrix and one listening matrix. What this matrix actually contains is the probability of referring one object with a certain sound. So let's imagine that two individuals is trying to communicate. Let's call them A and B. So they each have their own language, and as you see here, the individual A is trying to refer to his stone tablet, which is the object I now, and he does this by speaking the sound J. Then individual B has a certain probability of understanding this reference, and that is given by the speaking matrix from individual A, P, and the listening matrix for individual B that is given by Q prime. So when these two try to communicate, in the game we will get a payoff that is taken as the sum of these probabilities for all objects. And also, one important thing is that both individual A and individual B will get this payoff. So to get a high fitness in the game, you will not only require to be a good speaker, you need to be a good listener too. So, as I said, this payoff then is then interpreted as fitness, and higher fitness means that you will have a higher probability of getting similar offspring who will speak roughly similar languages to yours. So with these simple rules of the game, we can actually observe the emergence of language. So let's have a look. So in this simulation, we had a community of 100 individuals, and they could reference 5 objects with 5 sounds. So what is shown in this picture is actually the average of the community's speaking matrices. So in the beginning, we can see that their speaking matrices were randomly distributed. And already after 5 rounds, you can see that some objects is starting to refer to certain sounds. While after 20 rounds of the game, you can see that each object it can be referenced by one sound. But this solution is suboptimal since since one sound is actually referencing two different objects. While this is suboptimal, it's actually evolutionary stable. So this is a valid solution to this problem. But what can we actually learn from this? Not very much, actually. But basically, we can see that this model actually gives an emerging language. So, but to further study the evolution of language, we have to do some changes to this model. So let's update this game a bit. So in this updated version, we have the whole community speaking the same language. So we only have one speaking matrix and one listening matrix. And each round of the game, we introduce a different language. and then these two languages will face off to the death, and the surviving language will be spoken by the whole community in the next round. Also, we want to introduce some additional concepts. First of all, the concept of misunderstandings, which is kind of self-explanatory. We can misunderstand some references for other objects instead. Then also, we want to introduce the concept of object ranking, which basically means that some words are more valuable than others. For example, if you run into a leopard and a butterfly, the leopard has a chance to kill you. So the word leopard, saying the word leopard to your friend is very more valuable than saying the word butterfly. Let's do it. Let's have a look at what this simulation gives. Here. So in this game now, we have we actually want to describe 20 objects by using 40 different sounds. And again, you see here the P matrix, where on the y-axis this time the objects are also ranked. So the highest ranking object is at the top, and the lowest ranking object is at the bottom. What's interesting with this simulation is that even though we have twice as many sounds as we have objects, only 11 objects are referenced using 9 sounds. So this is kind of an error limit for how language emerges, and the way we can overcome this error limit is actually by combining these sounds and form words. So the next step of evolution language is word formation, and when we form words, we actually reduce the number of misunderstandings, while we get potentially unlimited potential for different object references. But the evolution language doesn't end there, because even though we have unlimited potential for different words now, we can't really describe everything with single words. I mean, if I could define a word that would conclude this complete presentation, we would have been done 20 minutes ago. But it's not that simple, because well, frankly, how would you learn that word? So instead, the next step is to form some sort of grammatical rules, because we need them to describe different events and different ideas. So actually, in this report, I've been getting this simulation from. They have additional simulations where they incorporate these ideas too, to show that some of these ideas that I have discussed with you could actually be really important when language emerges. But I want to move on to the end of our presentation and do a quick recap about what we have learned today. First of all, we talked about some history of linguistics. We mentioned some big names like Johansson and Ludwig Wittgenstein. And then we talked a bit about why studying linguistics is really important, because of how it affects our perception of the world. Next, we talked about how complexity science comes into this. About, for example, how language could be defined as an active process, and that when empirically studying linguistics, we can get some surprising patterns and some surprising patterns emerge, like this fractal structure, for example, Zipf's power law. Lastly, I showed you this simple simulation about how we could use game theory to study the evolution of language, and with this simulation we can see that simple sounds can create this error limit, and how we overcome this by forming words, and how we need to that isn't enough for a language. We need rules about how we can combine these words into sentences. So, on that note, I want to thank you all for listening.